7.5. Modeling data using logarithmic functions. Now, you've seen this lesson about 1,000,000 times now, no, just joking, but quite a few times. What I want to do is I just want to identify, or I want to show to you guys which linear regression we have to use here. So we go into stat, okay, and then scroll over to calc, and I scroll down, and I want to go to this ln reg. Okay, so this is the one that we're going to be using. Some people want to go into logistic. Don't do that. It's ln reg. So I'm just going to write that down. We use ln reg. And essentially now, folks, all we're going to be doing is doing two examples, all of which the type that we've seen before. The only thing is we're using we're using logarithmic regression, specifically natural logarithmic regression to graph this thing. So example number 1, using logarithmic regression to solve a problem graphically. The flash on most digital cameras requires a charged capacitor in order to operate. The percent charge, or Q, remaining on a capacitor was recorded at different times, t, after the flash had gone off. And remember, time is in seconds as identified in the graph or in the chart. The t.5 flash duration represents the time until a capacitor has only 50% of its initial charge. The t.5 flash duration also represented the length of time that the flash is effective to ensure that the object being photographed is properly lit. So, using this table right here, A, construct a scatter plot for the given data, B, determine a logarithmic model for the data, and C, use your logarithmic model to determine the t.5 flash duration to the nearest hundredth of a second. So first things first, we need to put this into our calculator. I'm just going to go stat, edit, and I have done this already. I'm just going to double check it. So 100, 90.26, 73.9, 60.51, 49.54, 40.56, 0, 1, 3, 5, 7, and 9. Good. So what I'm going to do is I'm going to graph it. And so for my x, so this guy right here is always going to be our x, and it goes in our L1. This is always going to be our y, always going to go in our L2. So I'm just going to change my window settings so I get what I want. So we go from 0 to, from 40.56 to 100. So I'm just going to say my minimum 0. My maximum, we can't go past 100%, but I just want to see the end of that graph. So I'm going to go to 110. This one right here, we have very small. It goes from 0 to 0 to 0.9. So I'm just going to go 1 or 0 to 1. And I'm going to make sure that my plots are on. So I go second Y, enter. And I'm going to hit enter here to put my plots on. I'm going to graph it. Oh, look! There we go. That's really great. So we're noticing the data here is falling like this, approaching this horizontal line. So we have accomplished A. What I want to do is now B, so I'm going to quit this, and I'm going to go stat, calc, and then go all the way down to number 9, which is my ln reg. Not lin reg, but ln reg. Enter. I'm going to say second L1, comma, second L2, comma, vars, y vars, enter, enter, enter. And so what I'm noticing here is that my form is in y equals a plus b ln x, okay, natural logarithm of x. So for my a, I'm saying 0.4596 though, so it's going to be 0.460. So y equals 0.460. And then my second one is going to be negative 0.099, but then we have the 8, which rounds it up. So this is going to be minus 0.100 ln(x). So that is my logarithmic equation. Let's see, it says right here, use your logarithmic model to determine the t.5 flash duration. Remember, the t.5 flash duration is when the x is 50%. So to the nearest hundredth of a second. So we're going to say x equals 50. And we're going to determine what our y value is from that. So remember, since we're given the independent, we're going to use second trace value. We're going to say x equals 50 and figure out what y equals. So I'm going to do this. I'm going to go graph. Let's see what it looks like. So I'm going to go second trace value. I'm going to say x equals 50. What does my y equal? So my y equals 0.069. But we need to get this into a hundredth of a second. So 0.07 seconds, because hundredth is 2 decimal places.